Have you ever stuck your paddle into the sediment and seen gas bubbles? I have, and you often see them popping up to the surface, even in a clean lake like this one. Those gas bubbles are made out of carbon dioxide and methane, greenhouse gases, as well as some hydrogen sulfide and other stuff. If you've seen this, then you already know how this story comes out.
Hi, my name's John Downing, and I'd like to tell you a little bit of a story about how fixing up eutrophication in coastal zones and lakes and oceans can reduce greenhouse gas emissions and have a fair bit of social value. A lot of us concentrate on aquatic systems as just places where carbon goes, but as the video I just showed you demonstrates pretty well, I think there's a lot of gas coming out of lakes, especially the green lakes. And so keeping those gases from increasing over time really will decrease the rate of climate change. So I just wanted to talk about that real briefly um, and give you some reasons why. Now in Minnesota Sea Grant, we work on all kinds of aspects of what we call the Great Lakes blue economy, many parts of it. But one aspect that's really important to us, especially with respect to greenhouse gases and climate change, is tackling pollution in aquatic systems, trying to decrease pollution or keep it from happening more, because it really has a big effect on um, a big effect on climate and actually on local tourism and everything else. So we work a lot on that area as well. Um, Carbon is really important. Looking at how carbon moves through systems is real important to people, and this is um, basically because people are super interested in it because they're very concerned about climate change. You'll see this graph of news coverage of climate change over here, and climate change in all kinds of systems is increasing rapidly. But if you look at how greenhouse gas coverage by journalists is increasing, that's here, and carbon burial, which is carbon sequestration, is also increasing. And increase in public interest and journalist interest is super important um, because press coverage, public interest, and policy impact, like funding and policy change, are really strongly related. So if topics are being covered by the news media, people are interested, journalists are interested, and quite rapidly, the literature has shown that policies begin to change in order to react to public interest. So both greenhouse gases and carbon sequestration by marine and freshwaters have attracted a lot of journalists' attention recently, increasingly when normalized for word usage in the news. And about 50% of news mentions of climate change all by itself concern marine or fresh waters. So greenhouse gas emissions or uptake are seen about 10 times more in the news than carbon burial, and so greenhouse gas emissions might be important. A lot of governmental policy these days is oriented toward getting carbon to be stored in marine systems, and I'll make the case that we also should be really careful about any implications there are for greenhouse gas emissions. Sometimes when we increase production to increase carbon storage, we actually are also driving up greenhouse gas emissions and can really blunt the effect of the desire to bury carbon in aquatic systems. So the lakes and oceans are really important in regulating global carbon and greenhouse gas flux. They're important to climate change in these ways. This red circle on top shows a release of CO2 and methane. Also, nitrous oxide is released quite a bit. There's also some uptake, but in general, lakes are emitters of these greenhouse gases. Um, they also are really important in sequestering carbon, taking that carbon and holding it for long periods of time so it doesn't get into the atmosphere. So, a couple of aspects of why lakes and oceans are important in regulating climate change are having to do with the emission of greenhouse gases and also sequestration or um, burial burial of carbon. So lakes, especially green ones, give off really a lot of greenhouse gas, and here these numbers are showing that about how much greenhouse gas are given off by lakes is by lakes in the entire globe, and it's measured in teragrams. And teragrams are kind of hard to imagine, but it's a whole lot of them, somewhere around 400 teragrams of carbon dioxide every year and 108 teragrams of methane released every year. And a teragram is just about the weight of the Golden Gate Bridge or the Chrysler Building. So you can imagine this is really a lot of emission from lakes. Atmospheric impact is high, and it's dominated by the impact of methane emissions. You can see that something like 3/4 of the impact on the atmosphere of lakes' greenhouse gases is driven by methane alone because it's just so active in the atmosphere compared to carbon dioxide. Nitrous oxide is not terribly important. I know a lot of people are concerned about keeping carbon dioxide out of the atmosphere, but compared to methane, it's coming out of lakes anyway, is relatively small. Methane's effect is really large compared to CO2, and this effect will increase with global eutrophication. Eutrophication being the greening of waters as we put more nutrients into those systems. So make them more eutrophic, more green, and you drive up methane emissions and cause more atmospheric damage. Marine systems, especially near shore, are also huge sources of methane flux. Over here on the left-hand side, you'll see the methane flux from, freshwater systems, aquaculture, reservoirs, lakes, and rivers, and they're pretty high. But looking also at estuaries, salt marshes, mangroves, seagrasses, tidal flats, etc., they're also in the same kind of range, maybe just a little bit lower. But as we know, there's a whole lot of coastal zone in the world, and so they can have sort of a big cumulative effect on global systems. So this is from a paper by Rosentreter et al. In Nature Geosciences, and they said that marine nearshore regions are expected to increase greatly in greenhouse gas emissions due to urbanization, to eutrophication, and climate change. And they suggest that coastal land use changes can mitigate increasing global impact, and also suggest that improving coastal water quality or avoiding degradation can help mitigate climate change, just the same as with lakes. So lakes and coastal zones, the area where Sea Grant works, the areas where Sea Grant works are very important to basically the gas emissions that can cause or exacerbate climate change. When we look at lakes, and the factors that impact greenhouse gas emissions. I'll just concentrate here on methane, but basically methane, regardless of the size of the lake you're talking about, be it Lake Superior or a little pond, basically the emissions increase really fast with increased trophic status or productivity. Here it's shown as by chlorophyll. You can measure it by phosphorus and other sorts of ways. So the more productive the systems are, or the more nutrient polluted they are, the more net methane they give off. And as we know, methane impact is about 75% of the atmospheric impact from lakes. So we can begin to cause increasing climate damage if we're not careful with our waters. Eutrophication itself, though, is a global and growing problem. This is the Baltic. You can see the green areas, lots of algae growing. It's the same. It's the same in marine and freshwater systems. Eutrophication from too much nutrients is increasing on the planet. So avoiding eutrophication or mitigating has climate change implications also for marine systems. And because greenhouse gas emissions rise quickly with marine and freshwater production, it's important to moderate the changes in that production or that rate of eutrophication. A couple of my coworkers and I tried to figure out what the aggregate effects from nutrient release and increased temperature and increased storms might be on eutrophication over the next 30 to 30 to 30 to 80 years. And we have, unless we make really big changes in the way we do things on Earth, we'll see an increase of 30% to threefold the rates of eutrophication by 2050, and increase by 120% to up to fivefold by 2100. This is basically all driven by population increase. So avoidance of greenhouse gas emissions it has a very large social cost, and this is very well estimated by economists. And this is basically a damage function. So you're damaging a lot of things by changing the climate. And the things you manage are shown here, or that you damage are shown here. Agriculture through agronomic changes, cost of crop adaptation, vulnerable markets that can be impacted by climate change are things like forestry, recreation, energy systems, water systems, construction, and fisheries. Coastal impacts can be damages due to sea level rise, resettlement, repair, and in some cases in the Great Lakes, lake level decrease is also a big problem that's also driven by more climate variation. Health effects can be very large because there's a thought that spread of tropical diseases will increase with increased um, temperature, and damage to cities' cultural resources are really can be extremely important. If you think about Venice, Bangladesh, these are very unique environments, but there are many of them around the world, and minor changes in things like sea level can have major impacts on those populations. And then there are the catastrophic impacts that we're more and more attuned to, sharp rises in sea level, increased storms, monsoons, runaway greenhouse effects, various catastrophic impacts. So any amount of greenhouse gas that we send to the atmosphere will increase the likelihood of these damages, and the damages are quite substantial. And economic models, of course, account for several costs of greenhouse gas emissions, as I've just said. And you get some sense that, it's worth right now about 2% of the global gross domestic product is due to climate change. And this is how it parses. A lot are due to catastrophic impacts and damage, a lot due to health. And you can see impacts on agriculture, settlements, vulnerable markets, etc. We did some calculations just to look at eutrophication change over time and what that is likely to cost the population of the planet. We calculated the present value of global social costs of methane emission from lakes and reservoirs between 2015 and 2050. And the numbers here you see, they vary a little depending on what actually happens economically, having to do with various discount or interest rates and so on. But the damages worldwide of that increase just from lakes alone is likely to be in the range of $6 to $90 trillion just for the future climate cost of eutrophication. Very big numbers indeed, and very big damage. And obviously, the more we can reduce eutrophication or or avoid it, the more of those costs we will avoid. And just to give you some sense of how big those costs are, even on a local scale, I thought we might want to look at the effect on Lake Erie. This is an image from NASA. See Lake Erie rather green to the west, various green places in the Great Lakes. Lake Erie has had major problems with nutrients and harmful algal blooms. It probably will become more eutrophic by 2050 due to various legal issues, urbanization, and industry. And studies have estimated the cost of further eutrophication on recreational fishes and beach use. And these are both local costs of eutrophication. So we wanted to contrast those local costs with more global impacts based on the social impact of greenhouse gases on climate change. And here are a couple of examples. The global cost of Lake Erie eutrophication generally exceeds estimates of local costs. On the top panel, you see fishing, recreational impact of $100 million, but into the billions for methane emission cost to the atmosphere. Beach closures are also an important issue. The recreational cost of eutrophication and harmful algal blooms in Lake Erie is running in the billions, low billions, whereas the global methane cost of Lake Erie eutrophication is much higher, maybe by an order of magnitude, a power of 10. So um, I think we can see that the effect of it's really important to look at controlling eutrophication. If we do so, we win at home by having better water quality, better fishing, fewer beach closures, but we also win globally by decreasing climate change costs, which are seriously in the next decades to be in the trillions of dollars of impact on the global GDP. So the eutrophication cost is high. And here's my concluding slide. Anything that Sea Grant programs or you can do to curtail or reduce eutrophication and poor coastal land use is going to alter greenhouse gas emissions. And this will have a really important effect both on social value and both locally and globally. Very costly to people to have the climate change. It's driven by greenhouse gases. Lakes, if we treat them badly, lakes and coastal zones, if we treat them badly, will increase their eutrophication and therefore their greenhouse gas emissions. So I thank you for your attention, and I hope this was of some interest to you.